Okay guys, in this video I will discuss about the prying action in any tensile force related connection. Okay, so first, before starting, I would like to thank you for joining this premium group, and now it's time to start. Okay, so before diving into the detail of prying force action, I would just like to discuss why this type of prying force is occurred. Okay, you know that in any type of moment connection, the flanges are connected with the flange of the column. Okay, so if this is the column and this is the beam, you know that these flanges are connected with this column. Okay, and you know if this is the bending moment, it is actually being converted into a compressive force and a tensile force like this. So here if you simply cut this particular part, you will get a tensile force acting like this, and this is the flange of beam. Okay, so this is the enlarged part, and here this is nothing but the flange, this flange. Okay, and this tensile force is being applied in this flange, and this flange is connected with this column flange by using some bolt. Here you can see. Okay, so now you have got that how this force is coming and how actual cases this type of situations are developing. Okay, now let's understand how these prying forces are being developed and what are the effect, okay, in our connection. So first, let's understand the meaning of this term prying. You can simply read out by pausing this. So prying is normally used to indicate something greater than normal cases. If you are applying some forces and you are resisting the member by using some bolt, definitely there will be some reaction forces in the bolt. It's very natural. And if we use the term prying force, that means these reaction forces are more than this applied force. Now how this can be possible? Okay, so that is the basis of discussing this topic. Okay, in normal cases, you know that in any type of moment connection, we normally just simply connect this flange by using some plate at the end and then some bolt like this. Okay, or something like this. So there are two type of moment connection. One case is the flange are simply connected with the flange of column, and second type of connection is where the flange is connected with the flange of the column by using this bolt, but in addition to this there is some extra stiffening member. Okay, so you can say that there are two type of moment connection. First one is unstiffened and second one is stiffened moment connection. Now if you have stiffened moment connection, in that case what will happen? Of course, due to this stiffener, this particular zone are much more rigid or stiffer. In that case what will happen? This tensile force will bend this flange. Okay, so now this is the flange of the beam and this is the actually flange of column. So this is flange of column and this is flange of beam. If you have any confusion, please slow down or simply pause and try to visualize. Okay, so if you have stiffener, in that case this is a rigid, these are the stiffener, these are the stiffener. Okay, just go back and try to visualize. This is the flange of beam, and in the flange of beam, both at top and bottom we have stiffener. At the top we have external stiffener, and in this zone the wave itself acts as a stiffener. Okay, so if you have stiffened moment connection, in that case this type of system become very rigid and the flange of this column bend uniformly, or the flange of the column bend with unicurvature. Okay, and as a result of which what happened, these bolts simply act like a single bolt, and this is the force. So if this is the force F, the reactions force are F by 2 and F by 2. This is okay, there is no problem, because in this case there is no extra deformation or excessive deformation. That is why the externally applied load and the internal reactions are equal and your connection is safe. Now what will happen if we do not have stiffener? Just like this case. Okay, so if you do not have any stiffener, in that case what will happen? The deformation will be much larger. Let's say simply this is the column and this is the beam, and at the end you have put some plate. Now these are the bolt, these are the bolt. Okay, now if you have moment like this, here is the tensile force, here is the compressive force. Okay, now this joint is not at all stiffened. You can say, well, it is stiffened at the bottom only because of the wave of the beam, but at the top there is no stiffener. Okay, so it is unstiffened. So in this case, this tensile force will cause much more deformation in this zone. Okay, so here you can see there is a large deformation, and due to this deformation, what happened at the end of this plate? This is the end plate, this is the end plate. So at the end of this end plate, what happened? There is some external extra thrust is being generated, because you have applied some force. Initially this was the plate, this was the bolt, this was the bolt. Now as it is not stiffened due to this externally applied load, what has happened? It has deformed excessively like this. This is the deformed shape, and due to this deformed shape, what is happening? Simply it is applying some extra pressure to the flange of column, and in return it is getting back its prying force. Here this Q is actually coming back from the flange of the column due to the pressure created by this end plate because of the excessive deformation. Okay, and now what will happen? You have some extra force Q. Okay, so if you simply draw the bending moment diagram, what will happen? At the end, due to this Q force, you are creating some bending moment, and also here due to this external load, you already have some bending moment. So your plate is subjected to bicurvature. Okay, so here is the bending moment diagram. This is the externally applied load P, this is the reaction force, and there is extra prying force Q. Okay, so now if you simply draw this bending moment diagram, it is something like this. So here you can see this is point of curvature, this is point of curvature, but initial cases, here you can see the bending moment looks something like this. As there was no prying force, the flange plate was subjected to uniaxial bending. Okay, so now you have understood the effect of prying force and why we normally use unstiffened connection versus stiffened connection. Okay, so that's it.